And if you notice here, this is the hash rate that we just went over the query for it. So if you, it goes up, and then bam, Dow fork. The Dow fork drops the hash rate for Ethereum Classic, and then it's like
the summary that what you're going to cover today, okay? And then make a just say, okay, so now we'll go into the share screen, right?
We all know how my introduction begins, right? Don't we all know that I start talking about the immutable fortress,
immutable fortress,
Emerald City, where the law of the land is code and the grass is always greener. Welcome to another episode of Explore the Chain with ETC Labs. And today we've got Yaz Khoury from ETC Co-op.
Thank you. Very happy to be here. Thank you, Dean.
So happy to have you, Aquaman.
Appreciate it. Yeah.
I know we're going to put that picture. I'm going to put that somewhere in this video.
Oh, yeah. Yeah, Donald can be quite creative.
I love it, man. So I want to first frame how amazing Yaz is and why it's such a big deal to have Yaz not only on the show today, but in general with ETC. He is one of the first people to walk on the moon. Isn't that correct? Aren't you part of NASA?
Yeah, I was part of NASA.
That's crazy, man.
No, but I mean, like, technically I did, it was more like a volunteer.
Okay.
So basically what we did, we worked on we volunteered a project for a NASA competition for 3D building habitats on Mars. And
3D, I do that all the time.
But so what happened, my background is robotics before I did software, right? So robotic engineering, and like basically it was a team of architects, and they designed a Martian days made out of ice, right? And like the architecture was amazing, like something I've never seen before. The problem was they didn't know how to build it with a robot. And that's where I came in. Like me and my friend, we specified, so this is how a 3D printing robot would try to build like a circular kind of structure, like a cone out of ice. And we made it very feasible. And because of that, we won the first place in the NASA competition. And now they're using our design to actually build a base on Mars.
That's insane, man.
So I really love space. Like before crypto, I was like in space. I loved it. But like, because I'm a Canadian, I can't really join NASA because I'm like a foreigner, like not a U.S. citizen. I'm a Canadian citizen.
Is there not a Canadian version of NASA?
Yeah, I can join the Canadian version of NASA, but I have to also be a perfectly well-spoken in French. Like I didn't want to learn French. My whole family speaks French except me. I speak Mandarin.
So, I mean, that's a great. I love the journey. I love what you've learned, and then coming here to ETC recently, there's been a big update, a big accomplishment on your part, which is getting us involved in Google's BigQuery.
Yeah. So Google BigQuery was such an interesting project because it introduced me to a lot of Google engineers who are like always thinking in terms of scale and how to create infrastructure for the public that is scalable, right? So that was one interesting thing. The other thing was the data science aspect. Being exposed to a lot of people in data science who are like trying to analyze the blockchain. And for me, it's like give you a lot of insight. Oh, would it be cool to like analyze this part or like see miner reward over time? Like there's a lot of aspect of it. So all this stuff came together, and they approached me for adding Ethereum Classic to Google BigQuery, and that's the project that I worked on. And we wrote a Medium post about it with all the different data analysis that I've done, and I'm very happy.
I'm going to share all of that in the links below. So just so I can kind of understand the magnitude of this, can't I just Google any blockchain? I mean, aren't all of them available for me to kind of get all that data for? Why is this special?
Yeah. So currently, if you want to get the information from the blockchain, you'd go to an explorer, right? The problem with the Explorer, they provide you an API endpoint where you can specify, oh, give me the information for this block. And from this block, I want like maybe this transaction, right? But it's so limited in scope because I can't say I want all these blocks from this date to that date, and I want them and like I want this specific parameter. You would have to create API endpoint that can do that, or you'd have to have some sort of language called graph query language, which is like an API for querying, which is
Well, even though the data is all out there for all the blockchains, because from the public blockchains, even though the data is out there, there needs to be specific work done to be able to extract it so easily.
right. So with that, because of that you limited from the API and the Explorer, you would have to manually parse the blockchain yourself to get all that data in a structure that you want. And after that, you'd have to do it continuously in order to have like up-to-date data. Because let's say you're analyzing from point X to point Y, and then a few months go by, you're trying to see, wait, does my data analysis still hold up now? Like given, so you still have to do that, information all over again. So the big deal about BigQuery is I don't have to worry at all about data engineering, about figuring out running my own node, parsing it, uploading that data, and then doing my analysis. I can just query the data directly and just focus on my analysis. So I can focus on the data science, and Google focuses on the engineering part.
But why? I mean, what was so special about ETC that Google wanted to do this? Is it because that you know someone at Google, or what did they see about ETC that made it?
Okay. So like the story first started, Anthony wanted me to do Gini analysis for Ethereum Classic to begin with, right? And I was looking at ways to do it easily because I like to do repeat analysis, over and over. There was no easy way to do it, like given the reason that I told you before about the block explorer and stuff. But I Googled online, and what I found out, Google BigQuery already worked on Bitcoin and Ethereum, and they have the project to extract Ethereum data. I contacted them on Twitter and I asked them, "Do you have can you show me how I can do it, on my own, so I can do my analysis?" And that's the only reason I wanted it. I wanted to do it on my own for Ethereum Classic. And they gave me a link, and then I guess they looked at my profile. They're like, "Wait, you work for Ethereum Classic. Do you want to can you want to help us put ETC on Google BigQuery?" I'm like, "Yeah, I mean, that's cool." And from there on, we started like working together, and yeah.
Amazing people building amazing things, and amazing things happen.
Yeah, I mean, it was like literally I just DM'd them on Twitter, and here we are.
So that's inspirational for everybody watching. If you want to get something done, do it yourself, reach out. Think how we have Yaz doing it. So today what I want to do is I want you to walk us through how somebody like myself can get access to this data. And then let's discuss some ideas about, what could I do? What could I start to learn?
You already have an account, right?
Yep.
So if you click on the link that I sent you,
Yep.
On the corner to your upper right, there's a button called Fork.
Okay.
So when you click it, it will copy my notebook, which is the link that I shared, to a copy of notebook for you on your account. And that way you can, mess around with it when we get started. So yeah, just click on Fork and it'll just pull it over to your account, and then you can edit it as well.
Got it. Okay, I've got it now. It says it's showed up. It's Dean Pappas's draft. It says your code isn't committed until I click commit. I've got it.
Okay, awesome. And so now that it's committed, can you tell me that your URL at the top, does it have a /edit at the end?
It should have /edit, you're saying?
If it doesn't, we can just click on edit. I just want to know if you're in the edit page or not.
It doesn't have /edit at the end.
Do you see an edit button around?
Do you see one? I see docs. I see input. Wait, I have to press commit first, right?
Oh yeah. So you first commit to save it, and then after that, it should be okay, and then we can just edit it after.
Okay. So first, I have to do the commit.
Okay. So it'll probably take like 30 seconds to a minute to do that, but
So what we're going to recommend is that the viewers use your link to get started. We're going to tell them to fork it,
run it,
and then commit, and then okay, complete it. So then I open version, and now I have an edit. Okay.
Perfect. So when you're in edit, if you click on the first part, because the notebooks are in chunks, right? So it's either a code chunk or a text chunk, right?
Mm-hmm.
The first one that says using Ethereum Classic dataset, if you click on it, here, look, I'm on edit right now, so sorry, it's gonna take a little second to load, but
We're great for time too. Like we're very comfortable. So you just tell us.
right, awesome. All right, so now I'm on edit. I'm clicking on this because so how do I go from one chunk to the next chunk? You click on Shift Enter. So if I click Shift Enter right now, it moves to the next one, which is the code. Import NumPy as NP.
Okay.
Right, and if we click it again, it would execute that code chunk. So if I run it now, if you see that one, it wasn't there before. That means it was executed, or the first chunk executed.
Oh, okay.
Yeah. So what this does is it imports some libraries from Python, NumPy and Pandas, and it imports BigQuery from Google, right? Okay. So after that, the next chunk that we're gonna do is a query, right? So this is just the text of it, what we're gonna be running. Basically, what we're gonna be doing is we're gonna be what are we clicking on? Okay. So we're counting how many miners per day discovered a block, right?
Okay.
Right. So and how many like each miner discovered per day. So that should give you every day who's the top miner as a query. And this is the query, right? So we select a miner, we select the date for that we want to go over. We select count. We count how many miner. We count the miner. So
Have a total
yeah,
block reward and
right.
for that date. Yeah.
And every block has a miner address. So if you just count how many miner addresses in each block, that will give you, and then you aggregate it per day. That should give you who's the top miner per day, right?
Okay.
And then we do it from BigQuery public data dot crypto underscore Ethereum underscore classic dot blocks. Blocks are the table, Ethereum Classic the data set. We're grouping it by miner and date because like then you'd have the top miners and you and then you put it by date and then we can continue from like the beginning of Ethereum Classic until today. And
wow, very cool.
yes, very efficient. And having count miner greater than 0. So that means that as long as
don't show me miners who have never.
Yeah, who never mined for that day. I don't really care about them, right? So right. So if I click on Shift Enter again, that'll take me to the code chunk here.
Okay.
Okay. Now inside here, what's happening is in a second. Okay, we're instantiating the client BigQuery. We client equals BigQuery.client, so that would generate the client for us for BigQuery. SQL is a string where we just basically we went over what we've written here. At the same time, we're ordering it by date miner descending, so that would go from the top miner all the way bottom per day. And we're doing that, and that would be easier to So that's the SQL string that we wrote. So DF is a data frame. Data frame is coming from what do you call it? Pandas. Data frame is think of it like Excel, but within a Python programming language. So you don't have to like open Excel or stuff. You can modify stuff in code as if they're an Excel sheet.
Okay.
We call it data frame. It's very good for data scientists. So DF data frame is equal to client, which is what we just created earlier, the client for BigQuery, dot query. So we're telling that client query SQL. SQL is the string that we created earlier for the query. And then to data frame, we're moving it to a data frame. We're saving it as a data frame. Now, after that, because we saved it as DF, when we type DF after that, it will show us the result as a table. Okay, so I'm gonna write Shift Enter, and it's loading now. It's running a query. If you look at here, there's a star. That means it's still processing. Once the star moved to a number, all right, number 2 now. If you look here, we have all the data now.
So where the date, the time frame, where is that being selected?
The data frame?
Yeah.
The data frame is being instantiated here.
Like if I want to restrict it to only the last like month, what would I do?
Yeah, you can do that. You don't have to do it from the data frame itself. You can actually do it right away from the query.
Right.
Right, and then you can do where date is less than 1 month. Like so we can specify the query to be less than a month. So you can have the top miners per month. In fact, I actually even wrote a query for it earlier. I can find it for you where you like you have to do it by where month 30 days kind of stuff.
Yeah.
But yeah, you can do it directly from here. It's very easy. It's like an extra line. But here, if you notice here, we started 1970 because that's the first time a computer was in our system. So that's like when it first went online. That and then it jumped to 2015, 730. That's the first time it started mining. And yeah, this is pretty much it. You have 839. Like okay, so that one is 2019 March 6th, and today we're on the 7th. So it takes 24 hours to update daily.
And then we've this is ordering by the miner address.
Yeah, it's ordered by or by date, miner, total block, reward, descending.
Oh.
And it's in total it's like 100K rows. Wait one. Yeah, sorry, I'm just regenerating it to show you. Yeah, if you look here, it says 100,869 rows. So that's like the top miner from the beginning of like I think it was July 2015 until now. And then what happened after? Now we go to the most important part: data frame, and then .2_CSV, and then we save it as etc.csv, and that saved it. Now, when you save it, what happens is because you're in edit mode, you won't see the file right away.
Okay.
But now that did you run it?
Yeah, mine. It's showing a number 3 next to it, where yours shows a 4.
No, that's fine. Wait, did you run the one before it? Did you run the client query one?
I'm doing that by doing Shift Enter or just Enter.
Shift Enter, that would execute.
Okay. Yep. Did it.
Awesome. So it could show you this like an output. At the same time, if you execute df2_CSV, that should save it. Now, once you save it, once you run it, it saved it to your machine, but you won't see it right away. So what you want to do is commit this after you run that.
Okay.
All right.
And then I have open new version or return to editor.
No, you don't have to return to editor. Now, if you go to the corner here where you see an arrow,
yeah,
they'll take you out of the editor and to the main notebook where you worked on, right? And over here, if you scroll all the way down, not Ethereum Classic, that's the data set. Under it, there's if you see here, etc.csv in an output file, and you just download it. And that you click on download, and it downloads it for you.
Awesome.
All right, try to open it. It's like 100,000 rows, but shouldn't be too bad to open with Excel.
Yeah, and it looks like did I run it twice? Maybe. No, wait. Yeah, this is perfect.
Awesome. Yeah. So that's like the gist of it. Is it's not immediately clear at the beginning because of like how they organize it. Because the reason they have output files organized like that is because in case you want to submit it to a competition on Kaggle, which is why they do it like that. It's not they don't do it just for you to download it for yourself, I think. But and if you look down here, this is like a preview of what you generated
Right.
over here. So yeah, and then it's pretty much it. So the fun part is as well what kind of query you want to run, you know, and
Yeah.
that would correlate with what kind of output you're looking for. And you can also save a step like when you have the data frame, you can have it like a sneak peek into your CSV file before you create it. So you know that, like a sanity check to make sure everything is okay. Yeah. So within Kaggle itself, actually, yeah, it's right here. The data is right here. So this is Ethereum Classic blockchain. This is where the data set actually is hangs out, if you will. And over here, we have a lot of information about it. Yeah, so you get a context what Ethereum Classic is, but more importantly, you get information about the tables that we offer in the data set. So the data set has about I think it was I say seven, seven. Okay. So you have blocks table would give you information about the block itself, and it will give you timestamp, the block number, hash, parent hash, and a lot of more useful information in case you want to do more deeper analysis. For example, minor difficulty, any extra data for that block, the gas limit, and the gas use. Um, Contracts um, it's specifically for transaction that created a smart contract where you can do more analysis on the smart contract stuff and it give you an address, bytecode, and you can start doing traces within the smart contract, like the to address, from address, transaction hash. Traces in like contracts can be useful if you want to, like, for example, analyze CryptoKitties on Ethereum, or you want to analyze the DAO fork on Ethereum Classic before and after the hard fork. Like if you want to look at the DAO smart contract to see the event leading up to the hack, you can technically do that, and you can actually graph it if you want to.
That's awesome. I
Yeah,
feel like there's a lot of a lot more to cover.
you see, like my problem isn't like the data itself or what you can do with it. It's just like finding time to actually do it, all of it, all that analysis. At the same time, getting like computing power because some of it might require like heavy CPU to do like machine learning analysis or like graphing a lot of data points at the same time. But like honestly, like the biggest problem is already solved: the data. You already have the data. Now, what do you want to do with the data?
Yeah. No, and to speak more about that issue, one of the things we're going to be pushing forward is some sort of developer challenge or grant.
Mhm.
Let's work together on figuring out some of the things you wish you could work on if you had more time. I think the
Yeah,
community could really help us on that.
yeah, I think that'll be awesome. Yeah, for sure. Yeah, so this data set for Ethereum Classic Blockchain is found on kaggle.com/BigQuery. BigQuery, Google BigQuery stores it here. And you have it on crypto-ethereum-classic.
Yeah, we'll add all the links below the video to make sure everybody has all of these resources that we've gone over. And then also, I want people to use the comments area to be able to add some ideas, ask more questions. We're always available on Discord. We're always very active also on Twitter. Yes, this has been fantastic having you and very informational. I hope I have some time today to start geeking out with the data myself.
Yeah.
Is there anything you would want to warn me about before I start poking around? Is there any way I can break anything?
I think it's pretty safe for you to break stuff. Like it's designed for you to be able to break things without worrying because you're not, you're just in charge of analyzing the data. You don't have to worry about what happened to the data if you analyze it, like the aftermath of analysis. But yeah, I mean, the one thing I would like you all to keep in mind, though, if people coming to this from like SQL background, like the Google BigQuery SQL itself, it has a slightly different format than regular SQL, but it's nothing crazy. Like it's just like functions might be named differently sometimes.
Okay.
But
If
other
anybody has a problem, they can definitely reach out.
yeah, but like other than that, like there's nothing to be worried about.
Excellent. So everyone, you've heard that if you want to learn something, if you want to do something, just reach out. You'll get it done. Yaz is a fantastic role model for us. Thank you again for your time. Thank you again for making this happen.
Yeah.
Everybody out in ETC land, have a fantastic week. We'll see you guys next week. Take care. Thanks, Yaz.
Sure.